Well, I think that we may start. So I will have a short introduction and then the others will join if they will join, of course. Okay, so let's see. Okay, can you see the presentation? Yes? Okay, perfect. So basically, today's presentation will be on greenhouses for cultivation in Mediterranean climate. So it's not directly related to hydroponic, but I think it's a very interesting topic for our demonstration cases and partners. So as you can see, greenhouse technology is spread all around the Mediterranean area. And this development is something of the last decades. You can see here two pictures of Almeria region. Almeria is a region in the south of Spain, very famous for greenhouse cultivation. And you can see that from the 17th until 2000, the increase of greenhouses was huge in the area. And this related to the fact that the heating costs in the Mediterranean during the winter time are, of course, lower. And for this reason, the cultivation in greenhouses was moved from cold regions to temperate regions. Here you can see some examples of greenhouses for Mediterranean, for arid and semi-arid climates. Of course, these kind of greenhouses are very different from what we may find in northern latitudes. And later we will see more in detail. And these greenhouses are adapted to arid climates, so climates that are characterized by very long and hot summers with temperatures above 35 degrees sometimes, and elevate solar radiation, dry and dusty climate with very low relative humidity, and also are also characterized by limited water availability and often availability of saline water. So the optimal characteristic that a greenhouse should have in an arid and semi-arid regions are, first of all, a good light transmissivity, which is something fundamental in general for plants cultivations. And this good light transmissivity can depend on the greenhouse structure and on the covering materials applied. We should have also an efficient ventilation and an elevated volume and a good insulation from the sand outside and the pests, and also a good wind resilient structure, mixed cooling system, and whenever possible, we should also have a desalination system or a system that could allow a recycling of the water. So the so-called closed loop system that we saw with Gaia in the previous meetings, in the previous workshops. Here, again, some examples of common greenhouses in the arid and semi-arid regions. So as you can see, in these regions, we mainly have low-tech systems, let's say. So, for instance, plastic tunnels or more advanced systems covered with net in some cases to allow a good ventilation inside the greenhouse, but contemporarily avoid the entrance of pests. I think these kind of greenhouses are typical of Israeli region. The orientation, as we said before, is important for the light transmissivity inside the greenhouse. In general, the best orientation at latitudes above 30 degrees is an orientation of the longer axis of the greenhouse with the east-west orientation. In this case, the best solution is to have a sloped rooftop with a slope of 30 degrees, because in this way we may have the best light transmissivity inside the greenhouse. If it's not possible to have this orientation, it will be good to have a greenhouse with a low pitch, since having a low pitch, a low slope of the greenhouse maintains the same conditions in both east and west orientation, and we may also keep a north-south orientation in this case. Here again, what I said before, so a low pitch, a low slope can reduce the differences in transmissivity between an east and west orientation and north-south orientation. Here you can see the fact that having a slope of the rooftop of around 30 degrees can allow the best light transmissivity inside the greenhouse in case of east-west orientation during winter time. That's the fact, because of course during winter time the sun is lower, and having this kind of pitch and slope, sorry, and east-west orientation can allow the best light entrance, light transmissivity inside the greenhouse. So the greenhouse structures in the the greenhouse structures in the Mediterranean are often characterized by application of locally available materials, often with low cost, are normally a structure easy to build and with low durability. So there is, in general, a low investment on the structures in the greenhouse, in the Mediterranean greenhouses, of course, to reduce the investment cost. Here an example, here an example of a greenhouse of the Mediterranean area constructed with recycled materials. In this case, we are in Venice, and the greenhouse was built with recycled railway elements. Of course, this is very cheap and let's say environmentally friendly, because we are reusing materials, but of course this is not the best condition in terms of light entering in the greenhouse, because using these huge poles may determine internal shadings that can consequently determine an inconstant yield inside the greenhouse. Here another example of Mediterranean greenhouses constructed with locally available materials. This is the case of Almeria. Almeria was famous for the cultivation of table grapes using this system called the Farrell system. And these systems were recycled in Almeria to construct greenhouses. Again, here in Portugal, you may know that Portugal is very famous for eucalyptus trees, and in this case, the greenhouses are constructed with eucalyptus poles. But again, this is not the best solution, of course, because the poles can determine shadings and also can become rotten and may need to be changed frequently. So, are the Mediterranean greenhouses sustainable? Well, probably at the moment they're not very sustainable in terms of climatic conditions. Indeed, there is a very low climate control in the Mediterranean greenhouses that, as we said, can determine very low cost of cultivation, but can also affect the yield, and that may be good and convenient only in specific periods of the year. So something important in the Mediterranean Mediterranean greenhouse cultivation would be to slowly move to more sustainable system with a good climatic control that may allow not only environmental advantages, but also a better competitiveness of production on the market. Until now, we said it before, this is a kind of repetition, but the climatic condition is mainly related to passive ways. So the climate inside Mediterranean greenhouses is mainly based on seasonal climate outside, based on the greenhouse effect of the greenhouse itself, and also based on natural ventilation. here, it's something interesting. You can see here two examples of semi-arid and arid climates. So here we have Almeria, and you can see that during the summertime, especially in July and August, the temperatures can be above 30 degrees. So it means that during this period, the greenhouse cannot work without a climatic control. So there are only few months, only 10 months in the rest of the year that can be used to cultivate. But in arid regions, this is even worse without a climatic control. Here we have an example of Saudi Arabia climate, and you can see here that from around April until October, November, the temperature is above 30 degrees. And it means that without a climatic control, it would be impossible to cultivate inside a greenhouse. So that's the reason why we need to make a step to more sustainable system. The most important thing in greenhouse, Mediterranean greenhouse cultivation is, of course, the cooling. Concerning climate control, the main problem is to cool down the greenhouse. And there are actually many ways to cool down a greenhouse. That could be passive or active ways. So now we will see some of them very quickly. Concerning the passive climate management, we may ameliorate the climate inside the greenhouse by increasing the volumetric dimension inside the greenhouse. In particular, to have the best greenhouse volumetric dimension, we should have at least 2 meter cubes of the greenhouse for each meter square of a surface. And it will be even better if we may have 3 to 5 meter cubes of the volume of the greenhouse for each meter square of the window surface of the greenhouse to allow a good passive climatic control. Another passive way to control the temperature inside the greenhouse is the shading. So basically covering the greenhouse to reduce the internal temperature. This is something that can, of course, reduce the temperature, but that may also have an effect on the yield of the plants because, of course, reducing the light entering in the greenhouse when it is not necessary can have an effect on the productive capacity of the plants. In particular, there are two means to shade the greenhouse. The most common and the most applied in the Mediterranean area, since it is very cheap and easy to apply, is the so-called whitewashing, which consists to wash the greenhouse roof with a white powder, which is normally lime. And this can reduce the light entering in the greenhouse and reduce the temperature, but of course it is a constant covering, so it is not possible to modulate the light when it is necessary to have a higher light transmissivity inside the greenhouse. Another way would be to apply mobile shading system. So in this case, it would be possible to cover the greenhouse when it's necessary, and open this shading system when the light needs to enter. But of course, these systems are more expensive and are not always applied in Mediterranean context. Another way to reduce the temperature inside the greenhouse is the ventilation, the natural ventilation. So basically having windows that could be open or closed. Now there are automatic system that basing on a sensor can open or close automatically to regulate the internal climate in the greenhouse. Beside these passive ways, so ways that not require energy, there are also active ways that, of course, require more energy to work. One of the most common is the so-called fan and pad system, which is an evaporative cooling system. So it is based on the temperature reduction due to water evaporation. This system consists in having an hermetically closed greenhouse, and on two sides of the greenhouse we have fans on one side that pull the air out from the greenhouse, and on the other side we have a wet wall, which is called a pad, that allows the air from the outside to enter inside, to be recalled inside the greenhouse, and this air going through this pad, the air which is of course hot, passing through this pad, makes water evaporate, and this helps to reduce the temperature inside the greenhouse. Here you can see an example of the pad. These pads should have a relevant surface and a width around 200 millimeters, and it is important to have a material that can allow the water to the air to pass through this wall. And normally it is possible to use some materials like wood chips, or there are some specific plastic materials that can be wet and that can contemporarily allow the air pass through this wall. Here again, an example showing how this system works. So basically this wet pad on one side, and this fan that pull out the air from the greenhouse and recall hot air from the outside. Something important is to consider to have at least 1 meter square of pad surface for each 20 to 30 meters square of greenhouse area. And another important thing is to have always less than 40 meters from the wet pad between the wet pad and the fan. Well, concerning the fan, if the fans are placed leeward side of the greenhouse, it is the best solution. But if it's not possible to have it on the leeward side and we should have it on windward side, we should consider to size this fan 10% with higher ventilation capacity to allow the perfect air, the perfect quantity of air pulling out from the greenhouse. Furthermore, another important thing is to have this fan with a distance around on the greenhouse wall with a distance from 7 to 10 meters. And it is also important to have, if we have more greenhouse, one close by the other, it is important to have the fan at a distance more than 15 meters to the wall of the next greenhouse. So this kind of system, this fan and pad system, is the most efficient in Mediterranean climates because it can also allow an increase of relative humidity inside the greenhouse. But the main issue in arid and semi-arid climate is that we need to have high quality water, and which is something that is not so always possible to have in these climates. Where here you can see what may happen if we have saline water. So basically the wall, the pad can be obstructed by the salts crystallizing on the surface, and this of course can reduce the efficiency of the systems. However, there are some solutions to avoid this effect, for instance, by washing this pad with acid water. This can allow to clean the pad and have an efficient ventilation. Another system for actively cooling the greenhouse is the so-called fog system. So basically, the fog system works with a nebulization of the water inside the greenhouse, it is important to have also a window to allow the excessive vapor to go out from the greenhouse, and in this way to avoid pest outbreak. And also in this case, water quality is something important to avoid to have nozzle obstruction. So it is important to always check that the nozzles are working well and eventually change it. The last active way to cool down a greenhouse is the so-called refrigeration system. So basically having a refrigerator, but this system is the most expensive one. So it is not possible to apply it in every context. So the best strategy for the Mediterranean area would be to have a mixed strategy. So use natural ventilation together with evaporation. So for instance, a fog system or a fan and pad system, and prevent from heat inside the greenhouse by using coverings or shading. And this can allow to having passive and active ways, of course, can also allow to reduce the energy for cooling down the greenhouse. Here, I just reported that because Gertrude the last time has required for some data on the energy requirements for in this case lettuce cultivation. We did a work before and we found in literature some data relative to energy requirements in case of lettuce cultivation in indoor system, high-tech greenhouses, low-tech greenhouses, and open field. And here you can see that in this case, indoor cultivation, of course, has the higher amount of energy. Maybe this is something that Tanai could use if necessary. We can exchange on that. Well, anyway, reusing renewable energies is something very important to reduce the energy requirements for greenhouse cultivation in the Mediterranean, both to reduce the energy cost inside the greenhouse, but eventually also it would be useful also if reselling the energy produced by the renewable energy systems applied in the greenhouse, in the farm. Here you can see some examples of photovoltaic panels. Of course, the main issue of application of photovoltaic panels on greenhouses is the excessive shading, but there are now new systems that can be integrated in the greenhouses that they are starting to develop right now, that can be integrated on greenhouses and allow application without an excessive shading inside the greenhouse. So these systems are very interesting for the future because they may allow the perfect circular production in the greenhouse, self-energy production and plants production in the greenhouse. There are, of course, another important thing to consider in the Mediterranean is to improve the resources used. Here, I just reported some examples. I'm not an expert on these topics, but I thought it would be interesting to have this kind of ideas in mind. Here is a greenhouse irrigated with saline water. Is a system that basically uses the same system of the fan and pad cooling system, and the evaporated water is recollected and reused for cultivation of the plants. I will be very quick here because I'm not a very expert on that, but we can discuss it later. And again, another important example is this one. So using brackish water and exploiting the solar radiation to allow condensation of this brackish water and divide salts from water, and at the end reusing fresh water to cultivate the plants inside the greenhouse. Finally, another interesting system for arid and semi-arid regions is to use the seawater to cool down the greenhouse. So basically applying a heat exchange system, and in particular the water from the sea to cool down the greenhouse. It's another solution. Again, I'm not an expert, but something is interesting that we may consider for our regions. So that's it. Thanks for your attention. If you have any question.
Elisa, I have just a question because you know, English is my second foreign, or is a foreign language for me. And on your slide 40, I did not really understand fully the message but it was a language problem.
Okay.
I think it was the slide 40, number 40.
Oh, wait, maybe we can go through it. Can you see it?
Yeah, but it's 14. I mean 14.
Ah, okay.
40.
Okay, let's see. Could be this one?
Yeah, the 40.
Because I have this one as 40. Wait, I will go through it. What was it about? Sorry, Gertrude. Cooling.
But it said, you know, it says here at the bottom, it said 40. So this is 36
yeah, sorry,
now.
because okay, let's do this way. Okay.
It seems that some
because I had
kicked
to
out.
hide some slides.
Yeah, sure.
Maybe this one should be this one.
Yeah, what is lateral distance?
Lateral distance, it's lateral, it means like one beside the other, no? Like if we have wait, maybe I can try to translate it.
Is it at the long side or at the short side of the building? On the long side, and the evaporation of the water is at the short side. You know, at the if it is a rectangle,
exactly, like in this way. Like in this way, okay? You see?
No, but that's now here the cooling is on the long side, and then on the other side of the building are the fans, or how is that to be understood? Okay, so I misunderstood it. So both technical aspects are at the long side of the building?
Yeah.
But opposed to each other.
It's just it's just opposite, right? If I'm not mistaken.
Opposite sides. Exactly.
Opposite each other.
Okay. I misunderstood that. Okay, it was too quick for me.
I didn't understand it also at that point either. But when you said lateral, so Elisa, sorry, it's Ben. It's just on the opposite. It's just on the opposite side, irrespective of which side of the rectangle, right?
Yeah.
And when you were talking about the volume above a square meter, it means the higher the better, right?
Well, no, it's considering the volume of the greenhouse.
Yes,
I mean,
but
considering
per square meter, you said per square meter, it should be 3 to 5 cubic meters.
Cubic meters of the volume of the greenhouse. Each, considering 1 meter square, we should have 3 to 5 cube meters of volume of the greenhouse.
But that would mean it should be 3 meters high, at least, the greenhouse. Because if you have a square meter as the bottom, and then you put 3 cubic meters on it, it must be 3 meters high, at least, up to 5 meters.
Yeah.
right?
Could be.
Okay, so the higher, well, let's say up to 5 meters height.
Yeah, I'm not sure if it's directly related to
yeah, because you put 1 cubic meter on top of each other, right, Ben?
Okay.
But why are you talking about cubic meters?
Volume.
Yeah, but on this slide, there's not mentioned any cubic meters. It's only about square meters.
No, not on this slide. It was just another question to regarding another slide that Elisa had.
This one.
This one, exactly. Exactly. Okay. So it seems that either we can economize on energy or water, but from now it's not possible to economize on both.
Energy and water?
Yeah.
Well, it is possible to combine different kind of systems. We saw that there are different solutions, but of course, I mean, it depends on the kind of climatic control system we are applying, how we combine it, if there are new technologies, as we saw at the end, that we may apply to reduce some inputs or recycle some inputs, for instance, like brackish water and so on.
But is it, I mean, some of the examples you showed are quite high tech now for Alamira, you know, in Spain, or maybe, I don't know about Italy. They don't use very high tech solutions, right?
No. At this point, no, they don't. They don't. But the fact is that, of course, without using a good climate control system, you cannot allow the best production, and especially you cannot having a production during some specific periods of the year. For instance, during summer, in July, August, it is not possible to cultivate. And the plants are going to suffer, of course. So it is important to introduce a combination of a cooling system.
But then during summer, Spain could import the tomatoes from Germany instead of producing them themselves.
Yeah, it depends on what's the purpose, no? If you want to avoid to import and if you want to be a great exporter, for instance, in northern Mediterranean country, we have the issue of virtual water. So I wouldn't say to Morocco to import tomatoes from Germany if you want to increase your own productivity. Well, this is also an economic and trade issue that, of course, is not. I mean, it has to. It really depends on the farm purpose, no?
Yeah, but right now, a relatively water-rich country like, or water-abundant country like Germany is importing the virtual water from Spain, which is a rather water-scarce country, or from Morocco or from Israel. Yeah? So we are, I think, this direction, importing virtual water from water-scarce countries is worse than the opposite direction, if it makes economic sense, of course.
Yeah.
Okay.
Yeah, and plus it depends if you want to have your own production, if you are able to afford the price of a German tomato, of course. This is something probably not possible.
In summer, it's possible. Right now, the German tomatoes are not more expensive than the Spanish tomatoes. Right, Michael?
Sure. I also have one small question, Elisa. Probably I missed that out. What should be the capacity of the fans in terms of volume per hour, for example?
Oh, well, I can't remember now. I have it in another slide. I will send you by email. I have the calculation for that. There were some things that I had to cut.
Elisa, please, can you that information would also be relevant for us, because you saw the small ventilator we had at Igloo. That was just for demonstration, so I know we need something but just to calculate in ratio of the space to the capacity, that would be good if you have such information too.
Yeah, sure. I will share it. I will integrate in this presentation and later send it to everyone.
Thank you.
Okay, then if there are no more questions, I guess we have to shift to the other meeting place.